Hi there, and welcome to my final project for Info Visualization class. I'm Orion, and here we go. I'm thrilled. It took me a long time to finish this program, and I got it done. All right, I'm a mathematician. I studied the Collatz conjecture. Too long a story. I'm working really hard on a sub-problem within the Collatz conjecture. We're not going to do any of the deep math. I've built this wonderful, I'm very excited about this thing, little program to let people have fun with the Collatz conjecture. First choice you get, which arena would you like to play on? Each of these, they're a little different from one another. Let's just pick a nice sort of typical one. Well, we're going to go with the one from 0 in the lower left corner up to 40. Okay, so first mode I'd recommend trying out is the wander mode. I'm going to move this out of the way so I don't distract us. Wander mode. Every point in this graph on the left represents a world. If you want to see those worlds, simply click. Nice interactive. You get these nice little data visualization printouts on the right. I'm using a simultaneous printout of a couple different graphs. Basically, we can get a little zoom in on any one world in this window on the left over here. So if you click all the way off to the left, these worlds at the start of the Collatz plane aren't particularly chaotic, and you can see that by this nice chonky straight line. As we drift further to the right, that line branches and becomes interesting, chaotic, wild, a little nuts you might even say. I love the colors of these worlds. It's a beautiful place. It's a lovely, lovely math problem. So what are these colors? First off, blue over here represents worlds that are entirely convergent. Every dot here has some finite stopping time. Pink represents worlds that have a mixture of finite stopping times and divergence. These bands here represent nodes that are, shall we say, evaporating off to infinity. And orange represents worlds that are entirely divergent. So blue, all convergent, pink, mixture, and orange is all divergent. Now, the different colors within this represents different convergent loops. So the channel I'm using in this graph for different loops is color, but there's no reason we couldn't think about these things differently. So let's imagine we take each of these different loops and we stack them onto these little worlds vertically in the z-axis. You can, if you wanted, flip this graph. Let me get so you can see me for a moment. You could take this graph, turn it this way, and do a cross-section of it, so you can get a little teeny sense of that three-dimensionality. Let's take a look at that. Those I call loop seed graphs, choice number 3. We're going to take the same graph. Let's do a loop seed. Hopefully we'll get something good here. Pardon, I never quite know what I'm going to get when I click randomly. We'll see. Not very good, but we'll take it. A loop seed graph. So here, instead of, you do see the same colors. I wanted as much consistency across the different ways of analyzing the Collatz plane as I could. The colors are the same as before, but now each of those different loops is additionally placed vertically. So we're doing a sideways cross-section of that plane we looked at earlier. So I've had the technology to make this one part of the project for a long time in my life. What I've always wanted, though, and it took me a heck of a long time to figure out how to program, was closing this, the ability to actually get a full 3D printout of this thing. Check this out. Choice number 5. You can do a smaller zoom in like we're about to do, or you can look at the whole thing. And I got it running. I got it not easy, forgive me. You can look at the whole thing in 3D now. And so we've got the same colors as before. The various different loops are represented this way. And I know it looks kind of like staticky chaos and a little like hell, frankly. Let me try to show you a little more about what's going on in this image. And I know I'm running a little low on time. This project took me so long. Forgive me. I might have to go a little over time. 3D view. So we're actually going to be better served to choose a new rectangle and move. I'm going to move us to a slightly more zoomed in image of the Collatz plane. We're going to do a 3D image. We're going to go across this entire thing. Boom, boom. And when it's rendering, you can see the fact that there are these big structures going on. It's not actually chaotic at all. What it is it's a very, very, very involved three-dimensional fractal. And in order to really see the fractal nature of it, you would need to scan it with a fine-tooth comb. It's got these big, chonky beams going through the graph. And I've never gotten to see it before, especially me, the mountaineer, that it's not just a big line. It's actually a structure that's curving down. And you can see, I'm going to try to zoom in with my camera a little. Maybe not. That it's got these funny little diagonal chunks of a mountain-like landscape that's curving down and going sideways. I have always wanted to see this thing in 3D. I'm really glad I got to. It's very cool looking. Okay, moving on, because we're out of time. Other things that this lets you do, a big, really cool one is, I'm going to click on number 2, highlight certain loops. Ready? So we looked at all those different colors represent different loops. Let's graph that original Collatz AB plane only highlighting worlds that have the loop sorry. 3. Highlight certain loops. Let's start by turning off all highlights so we get a nice blank graph. And I'm going to only turn back on the colors for worlds that contain a loop at 1. Ready? And so we can just highlight that one loop. Let's now close that, do the same, but let's turn on ones that have a loop at 3. And remember, we're keeping the color consistency. It's important. This is already confusing enough. The least we can do for the audience is try to keep some things consistent. Oof, that's going to be a typo. It's going to break, I think. No, maybe not. Okay. So let's say that we take all those loops at 1. And we want to analyze what's going on. Well, those aren't all the same loop at 1. And the math on this I won't bore you with. Let's more deeply study one loop. Let's finally, I've always wanted to see this. Let's deeply study the loop at 1. Boom, and you get each of the different loops that have least element 1 shown up, represented by these different colors. And literally, I'm really excited. I've always wanted to see what in the world's going on. That is a complicated fractally mess, but it's all in there. Seriously, it's very interesting, weird stuff. Okay, let's see. I think return to main menu. I'm probably forgetting something in here. Yes, before I go, I want to show you video paths. These take a little longer to load. I don't want to bore you with having you sit here and wait for it to load. I've already pre-loaded one of these. This is a way of clicking 2 spots on the Collatz AB plane and getting basically a video to pop out of what's actually going on along that that path. Oof, did I? Not the most professional thing I've done all day. Sure, we'll just drag this one in. Okay, well, hopefully this will be good enough. My program also lets you, it's so much worse than the one I'm looking for. Bear with me for one last second. I'll try to do this very quickly. 8 minutes, I'm way over. Come on. Okay, well, we'll just have to go with what we've got. I'm sorry about that. That really was very beautiful. I wonder how I lost it. It is late, of course. Okay, I'll just show you the stopping times. You are able to take those same 2 graphs that used to be all the way on the right, the little glimpses at the worlds, and you can look at a video feed, basically. So we're moving across the Collatz AB plane, and you can look at the movement and the change, like the change over time. Now we're adding an additional time channel of changes over time to let us get a sense of this thing. And gosh, no, I'm really happy with this program. It's done a nice job helping us dissect the Collatz AB plane. I'm excited. Last point, I'm just a little proud of myself. It was a day and a half of really straight hard work, learning all kinds of new modules that I've never used before. This program that I whipped up, all of this is new stuff. I wrote this whole thing over the last very caffeinated day and a half straight, and it is 1,669 lines long. And yeah, I put a lot of love into this thing. It's a cool little program. All right, take care. Be well.